Professor Robert, you can start, please.
Okay, all right. Thank you so much for inviting me. It is certainly a great pleasure to share our research on cloud data security and privacy, with everyone today. The topic, is on data security in zero trust environment. Essentially is our research and experience from the cryptographic research to system implementation. All right. The agenda introduction is essentially a state what is the problem, and secondly, I talk about some of the existing cloud data encryption solutions. Then followed by hollow data security platform, that is a system we design and implemented. Finally, is the conclusion. Introduction. Well, today, many organizations have migrated their data to the cloud. The COVID-19 pandemic, because of these restrictions and limitations, working remotely is becoming more or less a norm for every one of us. And this trend, in fact, has accelerated the process of cloud migration. Well, the issue is security in the cloud has always been a concern, and data breaches is becoming a growing risk. This slide shows some of the recent industry reports. For example, the Thales Cloud Security Report found out that 45% of the organizations it surveyed have experienced a data breach versus 35% a year ago. So it's a 10% increment. IBM every year also do a cost of a data breach report. So in that report, it states that 83% of the organizations have experienced more than one breach in their lifetime. And moreover, once you have the data breach, the cost is very high. So for example, in 2022, the cost for an organization on the average is $4.35 million US, compared with a year ago, which is a bit less. So data breach in the cloud is very common, and once it occurred, is very expensive, costly to the organization. On the other side, we also have the data privacy regulations. So regulation, in fact, is one of the main drivers for cybersecurity. Well-known regulations, the EU GDPR, it imposes very hefty fine against companies who violate the GDPR. The fine can be up to 20 million euro or 4% of the annual global turnover. 2021, I think January, the California Consumer Privacy Act was enacted. So this it also imposes stiff penalties. So if you lost a consumer record, one record, the fine could be up to 750. So if you lost millions of customers' record, the total amount of damage will be huge. As last year, September, China also started this data security law. Very strict. For example, some of the clauses in the law is that violation will trigger penalty, fines, and even suspension of business license, revocation of the license. And also, the person in charge of implementing compliance will be personally responsible, have to take a personal penalty risk. So those are the, as I mentioned, are the main drivers for data security solutions or technologies in the cloud. Well, the natural question to ask is that why there are so many data breaches in the cloud? So we have been working in security for so many years. We have very strong cybersecurity industries, many products available, but data breach still taking the center stage. Well, I think the fundamental reason for there are so many data breaches is because today's solution, the design and implementation, follow the traditional security model. So what is the traditional security model? The traditional security model is designed for enterprise information systems, for a closed information system. So this security model assumes that the servers or the storage systems, they are totally trusted to perform access control correctly and to be able to keep your data confidential. So the assumption is we have total trust on the servers and the storage systems. The second assumption in the traditional security model is that we trust users. We trust users to keep their logged in credentials secure. So users are security savvy. Okay, so those are the traditional model. The problem is in the cloud, we have the zero trust environment. The traditional model does not apply anymore. In the IBM survey report, a cause of data breach, it mentioned that the top attack factor for data breach in the cloud is the compromise of the personal users' credentials or the misconfiguration of the cloud. So there are some statistics. For example, stolen or compromised credential responsible for 19% of the breaches. Phishing responsible for 16%, and cloud configuration. So the cloud, the service provider can make mistakes that cause 15% of the breaches. So the question is how to design a system, a solution, which is secure in the zero trust environment. Then the design, the assumption is that we have to recognize cloud have zero trust, and we must design our solution so that it can protect our data security and the privacy, even the environment is zero trust. So specifically, we assume the users are not security savvy. So for example, users may lose their credentials. So their account may be compromised by hackers. And the second, more importantly, we assume that the service providers are not totally trusted. They're not trusted to keep data confidential, but it's not, totally untrust. So we have to make certain semi-trust assumptions. So they're not trusted to keep data confidential, but they are trusted to not intentionally destroy our data, right, so that we can have the data availability. So this is the assumption we make in our system design. The system we designed is called Hollow Data Security Platform. Well, under the zero trust assumption, so we do not trust the server to keep our data confidential, right? Under that assumption, the most effective solution, in fact, is E2E encryption, end-to-end encryption, right? So when data is encrypted, for example, this chart shows on the left, we have the user, before he upload his data to the cloud, he will perform encryption of the data on his computer and upload ciphertext to the cloud. The ciphertext is stored in the cloud, in the service provider. Because the service provider only sees the ciphertext, so the service provider, even if it has misconfiguration, even if the user's account is compromised, so at the most, the hackers or the service providers, what they see is the ciphertext. So your plain text data is under protection. Well, this is encryption is a good practice. It's good practice even if the server is trusted, because as we mentioned, the server may make mistakes. So this encryption essentially follows the principle of defense in depth. Next, just a quick review on some of the approaches for the data security encryption in today's solution. Well, a common solution today, the service provider provides, is they perform encryption on users' data. So you upload your data to the cloud. In the back end, the service provider encrypt your data in storage. So when data is in storage, it is encrypted. But this approach is far from sufficient. So with this approach, we cannot eliminate the top attack factors. What are the top attack factors? Number one, user account being compromised. So with the back-end encryption, even if the user account is compromised, the server will just automatically undecrypt your data so that to make data available to the hacker, because the server is not able to recognize who logged into the account. And secondly, if the back-end misconfiguration is compromised, of course, data will be exposed. So this is a useful solution, but far from sufficient. The encryption solutions, especially encryption software solutions, are plenty. They are available. Some of them you pay a small fee, or some of them are freely available. But all those solutions, or most of those solutions, they are designed for individual users. Okay. As a user, I have my password. I can encrypt user password, I can decrypt user password. So because the whole system is designed for one user, there is no cryptographic key management problem. So the key management is essentially password management, which is very, very straightforward. Right. So those solutions, they are suitable for individual users, but not suitable for organization, for multiple user environment. So encryption and cryptographic key management, when you have multiple users, for example, enterprise environment, is much more challenging than these single user applications. Today, there are essentially two kind of approaches for cryptographic key management. The first approach is based on symmetric key solution, such as AES. So in this solution, the whole system depends on a key distribution center, and this center is online. All right. So when user is performing encryption on the left, so he will generate a key, encrypt his data, upload it to the cloud, and pass that key to the server. And the server will redistribute the same key to the potential users who are going to download ciphertext and perform decryption. So the KDC is involved all the time in every step of the encryption and the decryption operations. So the problem, the limitations of this approach is there is a huge number of keys being distributed, because how many files you have, right? How many keys the server, the center must distribute. And the KGC is always online. So it is a performance bottleneck. And most importantly, it is a security bottleneck. So if the center is compromised, your whole system is gone. The other approach for cryptographic key management is public key encryption. So public key, as we know, each user will have a key pair. For example, Alice will have a public key and a private key. The public key is certified. So certification authority will issue a public key certificate to Alice, right? So that the Bob, once Bob knows the public key certificate of Alice, Bob can use Alice public key to do encryption, to send ciphertext to Alice. Alice can decrypt. Public key encryption is inefficient, very high cost. The high cost come in two aspects. One is that the CA have to issue a public key certificates to users and have to distribute revocation list, certificate revocation list called CRL, right? To make the CRL available to every potential users. This is a very large operational cost to distribute CRL. The second aspect of the high cost is that when I perform a encryption in a multi-user environment, for example, my document is intended for 100 users. So I must perform the encryption 100 times to use each user's public key to perform a separate encryption. And it's cumbersome to use. It's not easy to use. It's not friendly because the data owner have to know all the potential users' public key, and he can perform one-by-one encryption. Well, one of the product example which exists today, I think this is a product from Google, just rolled out 1 or 2 years ago. It's called Google Cloud Workspace Client-Side Encryption. So this product, these services use the symmetric key solution. In the symmetric key solution, you have a key distribution center. So in the Google's solution, it is called third-party key access service. So this is provided by a third party. And as a user, as a client, which is on the bottom of the chart. So when user has a file to encrypt, it will generate a secret key to perform the symmetrical key encryption, upload ciphertext to the cloud, and at the same time, the client will pass the key to the third party. Wants to access the ciphertext, to decrypt ciphertext, they have to go to the key access service to request for the secret key and perform the decryption. So this is a typical solution for a when you have a third-party service which is online. Well, now let's look at our design, our solution for data encryption, key management for to protect data security and the privacy in the cloud. Well, the solution we have is called Hollow Data Security Platform, HDSP. So it is a platform for providing cloud data security and the privacy in zero trust environment. It provides the following services. The first service it provides is end-to-end encryption. So the ciphertext is generated at the data owner, uploaded to the cloud, and ciphertext is downloaded to the data user performs decryption. So the encryption, decryption performs at the end user, the devices. Anything in between during the transmission and the storage, all under protection. Because it's all under protection during the transmission and the storage, so it protects data security and the privacy, even if user login credentials is compromised. So this one you need some thinking to realize this. So even if my login credential, even if my account in the cloud is compromised, my data is still under protection. And even if the service provider is compromised or misconfigured, the data is under protection, all right? Because of the E2E encryption. But in general, encryption is easy. It's a very mature technology. The problem with encryption is that we must make the system usable. My data has very strong protection, but it must also provide very good usability. So what are the important aspects of the usability? The first is scalable access control. My data encrypted in the cloud, and those data must be shared with other authorized users. So that sharing process is access control. It's called access control. So this access control must be scalable and easy to do. Secondly, when data is encrypted, we want to perform a keyword search on the ciphertext. So even data is under encryption, we should be able to perform search, for example, keyword search to retrieve the corresponding document. And ultimately, we want to perform encryption. We want to use the data to perform a secure or privacy preserved machine learning operation. So that requires secure computation. Right? So those are the usabilities of the system. The third feature of the system is it must be friendly to system admin. So low operation overhead. Your cryptographic key management process must be straightforward, easy, right? And it must including efficient user revocation. Why efficient user revocation? Revocation is probably one of all the cryptographic key management system, because when a user change his or her job function, his or her privilege will change, and the previous key will no longer work. You have to generate a new key for the new position. Or the user's key is compromised, we have to revoke the user. Or when user left organization, we have to revoke the user. So key revocation is a daily operation, very frequent operation, and this process must be very efficient and must be transparent to the system operation. So you cannot, afford to have every time you have a user revocation, all my data in the cloud that will be too expensive. So we have the operation has been tested by quite a number of organizations. Below the hood of HDSP, we use the following cryptographic techniques. The first technique we used for scalable access control is ciphertext policy attribute-based encryption with after-sourced decryption, okay, with after-sourced secure search and secure computation. And so in the rest of the presentation, I will just explain what is CPABE and how it works, and what is the HTSP system architecture and implementation, and that's it. I will finish the presentation. Well, the CPABE is a new family of cryptographic encryption algorithm. So it was invented in 2006, and today probably there are hundreds of papers available talking about attribute-based encryption. This chart shows how CPABE works. So let's go to the chart step by step. So we have a KGC, right? KGC is the key generation center. So this is essentially is a computer embedded device, and it operates offline. So every time when a new user joins the system, the KGC will be in operation. After that, it will go offline. Well, each user in the attribute-based encryption will have a set of attributes. So for example, Bob will have the attributes, his organization, his position in the organization. Similarly, Alice, her organization, General Hospital, her position is cardiologist. So all those are the user's attributes. When KGC issue a private key for decryption, and this key is bound with the attributes. So the more attributes you have, the more access privileges the user will have. All right, so the attributes and the key are bound together. So this is for the data users. On the left, we have the data owner. ABE is a public key encryption system. So there is a public parameter. It's a public key. So the data owner only needs to know the public parameter of the system so that he can perform a encryption. So when the data owner performs the encryption, he has to specify an access policy. All right, access policy. So for example, the access policy for this who can access the file? That means who access means decrypt. Well, so if we look at the Bob's attributes is KC Corp Limited programmer. So those his attributes were not set. So Bob is not file to obtain the plain text. Right? So this is roughly how ABE works. Now, what are the, can you hear me?
Yes, please.
Yeah. So the network seems very unstable. Yeah. I apologize for that.
No problem. Yeah, maybe you can just disable the video.
Sorry? Oh, disable the audio, video.
Yes.
Yeah. I think very better. Yeah. All right. So let me continue. So CPABE is a one-to-many public key encryption system. So that makes the system encryption very efficient because I only specify the policy and only users whose attributes satisfy the policy are able to access the document. So it supports scalable access control, which is different from the traditional public key solution. Traditional public key solution, you have to perform many public key encryptions. The second feature of ABE is that the access policy can be very expressive to satisfy the business requirements of the organization. So essentially, any Boolean expression can be used as access policy. The third advantage is access control or decryption is built in mathematics. So it does not depend on the security of the cloud. It does not depend on the security of the service provider. Right? And even the service provider is compromised, you do not have the cryptographic key, you do not have the right attributes, you cannot access the document. So those are the advantages of the ABE, but the original design, the CCS 06 design, and some of the subsequent papers do not consider user revocation. So user revocation is a challenge, as I mentioned before. And so because of this, there are lots of research being performed on the ABE user revocation. I think I have to be very fast. Let me, I think I can skip the user revocation part, and okay, I will show you how it works, and then we can follow the have the Q&A session. Yeah. So this is our system design. All right. We have the client software. Currently, we those support Android cluster. So the server cluster is implemented in Kubernetes, which is the Google's state-of-the-art cloud computing architecture, which supports easy programming and easy deployment and scalability. And the public cloud can be any cloud. As long as the cloud support S3 protocol, then we can support that kind of cloud service provider. The user has a document he wants to send it to the cloud, but before it sends it to the cloud, the server cluster will do a file name mapping, because sometimes the file name can disclose a lot of sensitive information, right? So we translate the file name into a pseudo name, right? And so the file in ciphertext together with the pseudo name will be stored in the public cloud. So this file and the pseudo name essentially looks like just a sequence of random numbers. And the server cluster store the access policy. So what happened in the public cloud? Just a sequence of random numbers without even disclosing any metadata of the file. This is the implementation we have. It looks like quite complicated. Actually, it's not. Finally, I just spent another, let's say, 5 minutes to talk about how the system works. The first step in the system is that when user join the systems, so join the system user, for example, this user will have a set of attributes: name, staff ID, email, department, position, rank, etc. All those are her attributes. So those attributes, the KGC can retrieve from the HR database. So based on the attributes, the KGC will issue a private key. Okay, so the private key will be given back to the Alice. So Alice will store her private key together with the set of attributes into her computer or into a USB. All right. So this is one-time process. When user join the systems, you get your private key, and after that, that's it. Until the user is revoked, or until the user change the set of attributes, then the user come back to the KGC to get another new secret key. And for creating the encrypted folder, because in ABE, each ciphertext, before you perform the encryption, the user have to specify an access policy. So that will be too troublesome for the users. So in our implementation, the access policy are specified by the folder. So we have to encrypt the folder. For example, this folder, the big folder, the yellow rectangular box, has a access policy ABC Hospital. So ABC Hospital is the access policy of every files in this big folder. So as long as you have the attribute ABC Hospital, you can access the folder and perform decryption. And within the folder, we can have subfolders. So for example, the left subfolder, it has a access policy terminology department. That means only one, you have the attributes ABC Hospital and terminology department, then you can access this subfolder and decrypt the documents. Similarly, for the subfolder with cardiology department. And the access control is performed by two layers. The access to the folders are controlled by the server. Okay? So to the folders means who can create a folder, who can delete a folder, who can look into a folder, into the ciphertext within the folder. Okay? This part is controlled by the server cluster, by the system. And the second control is to access the file to perform decryption is controlled by ABE layer of access control. We have the second layer, which is controlled by crypto. And we can perform keyword search. So user can input the keyword, for example, urgent, and this urgent will be translated into a search token, which is passed to the cloud. The cloud will perform the search, retrieve the document which contains the word urgent. But the server is performing the search on behalf of the user without knowing the keyword, without knowing the plaintext document. And we can perform real-time access control, user revocation. When the user left the organization, even though he has a copy of the private key, he can no longer continue to perform decryption. Those are some of the screenshots. So let me finally to finish the presentation. Conclusion. So encryption is an effective means to protect data security and privacy in zero trust environment. And many cryptographic techniques have been proposed in the literature. There are thousands of them, right? And each year is published in top conferences. But most of those results, they are theoretical research, piecemeal solutions. By piecemeal solution, I mean they can only solve one problem, right? It's not designed to working together. And therefore, they have limited usability and efficiency on each algorithms on their own. Now, to design effective and usable systems, we have to carefully select and customize crypto algorithms and seamlessly integrate those algorithms into the systems so that they can work together. We can balance security, efficiency, usability, and also maintain backward compatibility. This is also very important. Well, the HTSP is a cloud data security and privacy protection platform for enterprise users. So it integrates ABE, attribute-based encryption, and the multi-user secure search. So I did not go through the secure search part because of the time limit. It supports two layers layers of access control. One is system level, another one is the crypto level. So it's like a defense in depth. And our key generation center is controlled by, this is user organization, all right? As a user organization, I control the KGC. I issue key to my users. It is implemented based on the state-of-the-art server architecture, Kubernetes. So this is for easy of deployment and scalability. I think with any questions they have.
Thanks, Professor Robert, for a very productive and informative session. We have received a few questions and I will go through them one by one. So the first question I will also type in the chat window for the convenience of our participants. It says, while performing encryption, decryption at the client end, will it take more time and make the system slower on the cost of security?
Yes, it depends on the, for example, our system is a file protection system, essentially. It depends on the size of the file. Normally today, given our standard PC, even mobile devices, the encryption can be very fast because the real implementation, the encryption is a hybrid encryption. We use ABE to encrypt a symmetrical key, and we use the symmetrical key to encrypt the large document. Symmetrical encryption is very, very fast. So the performance is not a big issue using encryption.
Right. Yeah, we have now latest devices which are all multi-core, so definitely it will handle this issue. The next question is asking, can zero trust be only implemented in enterprise cloud environment, or it can be used in any cloud environment?
I think the zero trust is essentially is like a paradigm. Depends on because in security, when you design systems, we always ask ourselves, what is the threat model? Even for zero trust, you can have different threat models. Depends on your weak security assumption or strong security assumption. So it depends on to the zero trust to what degree. And for certain systems, the zero trust means I don't have to perform encryption, but before I can take any action, I can grant any access control and do a double check. So it depends on the precise security model of the zero trust, on the precise definition of what is zero trust. It applies not only to enterprise cloud environment, but also as
Professor Robert, I think we cannot hear you. Professor Robert, you can unmute yourself. Yes.
Yeah. Okay. Yeah. Sure. I don't see the chat.
Now we can hear you. Okay. So there's one more question just came live from the participants. Should I read this question for you?
Yes, please.
Yeah, it says by one of our participants, will it take the least time in practice, or is cybersecurity something permanent that takes time in deciphering the codes?
Well, depends on the normally for decipher the codes, decipher I mean encryption decryption for symmetric encryption today is very fast. There are NIST standards for super fast encryption, for lightweight encryption. Those are the encryption algorithms designed for sensors, for IoT devices. So it really depends on the application. For example, if it's a website, we use end-to-end encryption. As a user, we don't feel the difference. There's essentially very little delay. Skype is using end-to-end encryption, right? A lot of public operations, before the session being set up. But once the session is set up, the performance is very fast. It's very good. There's no problem. For IoT kind of applications, because the devices very limited in terms of the resources, but it's normally it's not an issue because the data in the sensor data in IoT normally is very small. Yeah.
Right. So the next question says, does proxy server play any role in the cloud data security in zero trust environments?
The proxy servers, depends. Okay, if you are performing end-to-end encryption proxy server, the existence is transparent to the proxy servers, because in end-to-end encryption, the data is encrypted on my computer, and only ciphertext is transmitted, can be passed through network, through proxy, through other servers, and at the end users, it gets decrypted. So anything in between, including proxy servers, are transparent to security encryption. Even the proxy servers are compromised, your data is still under protection. But if the proxy servers are the point for decryption, then it have a strong implication to security, because if the proxy server is performing decryption, it have access to the plain text data. If the proxy server get compromised, then you get data leakage. Yeah.
Right. The next question I was asking, are end-to-end confidentiality solutions also using zero trust architecture?
Well, the end-to-end encryption is assuming we have a zero trust environment. Because we have the zero trust environment, we do not trust the network. We do not trust the servers in between. So that's why we performed encryptions from end to end. Right. So it's the assumption. We have the zero trust environment. Therefore, we use end-to-end encryption to protect our data in the zero trust environment.
Right. I think you answered this question, but I will ask again. You want to add more? It seems zero trust is good for desktop computers with higher processing power. Will it remain effective in low-end smartphones too?
No, yeah, it's smartphones today are very powerful. Even smartphones are multi-core today. In our experiment, there's not difference between a smartphone and a desktop computer. We don't experience any differences between the two platforms.
Yeah, some smartphones are like nowadays equal to the supercomputers we had 20 years ago.
Yes, correct. Yeah.
Okay, the next question is, how is the risk of internal threat mitigated in zero trust?
Well, the internal threat is, in a way, is very difficult problem to handle. But yes, in the zero trust model, in the assumptions, for example, we can also, for example, in our design, we do not assume the endpoint are vulnerable. We assume endpoint are trusted, are protected. But if the endpoint, which have the internal threats, normally happens on the client side and at the endpoint, there are also solutions, but not our solution. Our solution will not deal with the internal threats. There are solutions, you can download your data to the, to your machine, to the client machine, but you cannot copy, you cannot email, or you can email to a certain person upon the commission. You cannot print, etc. There are such copyright protection solutions available.
Thank you very much. This will be the last question. Perfectly, we are right on time. We have 1 minute more. So it says, what happens if a zero trust solution is also compromised? Will organizations' sensitive assets still remain secured?
Well, okay. So if the solution is compromised, normally one of the security principles we have is multi-layer of security, or the defense in depth principle. So if you have one, if the application is so sensitive, right? Normally you do not depend on one layer to protect your information. You want to add in extra layers. So if the zero trust solution is compromised, hopefully you can have another layer to back up. But if other layer does not exist, then you get a problem.
So, Robert, for a very informative session. We have ordained, so he would like to formally thank you and the participants. Dr. Abdullah, you want to say something? Yeah, thank you.
Yes. Thanks, Dr. Nasser, and I would like to thank our distinguished speaker on behalf of the Saudi Aramco Cybersecurity Chair and the College of Computer Science at Imam Faisal University. I would like to thank you, Professor Rupert, for sharing your deep experience in very new topic that's also very trendy, very important, which is the zero trust in the cloud environment. And would like also to thank the audience for their engagement, for their interaction, and making this platform a success. We utilize the lecture series to share the knowledge, the new technologies, and inspire the new researchers to develop and to expand in such technologies. And I believe with the security concern, the zero trust is very important. We need to review the conditions of the authorization and the authentication, and making sure if someone not authorized to stop that. And I believe Professor Report highlights very important the efficient verification of user for any reason. It could be for leaving the premise or leaving the organization, or there is some concern for their connection. And there is always a need to review the trust engine and the trust of such user. And hopefully you can collaborate with the Professor Robert for in the future for future research in this domain. Thanks again, the Professor Robert and Dr. Nasser for the excellent moderation of this session, and all our active members. Thank you all.
Thank you, Dean Abdullah. And sorry, I'm not able to turn on my video. I think it's okay. Just to say thank you for inviting me. This is an excellent opportunity to get to know each other, and hopefully we can have future collaborations.
For sure, looking forward for that, and there is a very good space for collaboration, and looking forward.
Yes, we will discuss offline. We have some opportunities to write a proposal for funding. Maybe from so we will discuss more details offline.
Okay.
Hopefully we can go for a bigger joint project with you and Scott Rose and other colleagues in this working in the zero trust domain. Thank you very much.
Yeah, thank you.